going to be showing you the steps of
how to build a calorimeter.
A calorimeter, we're going to need a insulated cup. We have a McDonald's coffee cup here, which is insulated, so it works perfect for us. Heat is not going to escape from here. We need a scale to measure how much water is going to be inside a calorimeter or insulated cup. Right now it's at 0, and we need to add water. For our specific heat equations at the end, we're going to need to know how much exact amount of water that's going to be here in mLs. So we're going to put water from this cup in here, and we have about 161 mLs of water, and we're going to use this at the equations for the equations at the end.
Once we have water in the cup, we need to take a temperature reading of the water before we put the coin in, and then we need to get another temperature reading after we put in the coin to see the temperature change.
We need to measure our quarter for our equations. So we're going to measure it in grams.
6 grams. As our metal, we chose a coin, a quarter. So then we're going to put it into the boiling water, and then we're going to put it into our regular water to see how it affects it.
Now that our quarter is boiled and heated up, we're going to take it out with a pair of tongs. Put the coin in here. Normally we would have a thermometer, but we couldn't find one to see the temperature change, so we're going to make it up, the temperature change in the equation, and that's it. That's how you make a calorimeter.
So now I'm going to explain the calculations. To begin with, we did not have an appropriate thermometer, so the temperatures were made up in order to help explain this. Okay, so 6 grams of an unknown metal was heated to 115 degrees Celsius and then placed in 161 milliliters of water at 20 degrees Celsius, which then heated up to 30 degrees Celsius. Now we're going to try to find the specific heat of the metal. But first we have to find the amount of energy that was released. So we have 4.186, which is known to be the specific heat of water. Then we have 161 grams of water, and we have 10 degrees Celsius. How do we get to 10 degrees Celsius? Here we have 20 degrees and 30. So what you do is you do the final temperature minus the initial temperature. So you do 30 minus 20, and that is equal to 10, which is how we got our 10 degrees Celsius here. And then when you multiply all of this together, you get 6,739.46 joules. Now to find a specific heat, we do this equation. So we do 6,739.46 joules, my bad. That is equal to the specific heat times 6 grams, because that's how much the metal weighed, times 85. How do we get 85? So to get 85, you subtract the 115 minus the 30, and you get 85. And when you divide the 6 and you divide the 85 from both sides, you get this. So we get 13.2 joules grams times Celsius as our specific heat.